In this video, I'm going to first cover how we add numbers together in base 10 as people, just how carries work and how our general process goes. Second, how we as people can add together binary numbers and how we handle carries. Third, how a computer might, or how we can code a computer to add two numbers together, two binary numbers together, using nothing but the bit operators. So without further ado, let's start with our first point. Just good old addition in base 10. So this is pretty simple, something we've all known for a while. We start by looking at our ones place. So right now we're adding 125 to 36. 5 plus 6 is 11, so we put a 1 here, carry the 1. 2 plus 3 is 5, plus 1 is 6. And then 1 plus our implicit 0 here is 1. So we get 161, and all is fine and good in this world. But for purposes that will be perhaps apparent later, let's try adding these two numbers together in a slightly different way, where instead of storing our carry number up here, let's store our carry numbers in a separate variable down here, and we will add all our carry numbers after calculating our partial sum, or part of our sum. You'll see what I mean after running through an example. So, for starters, there is no carry here because there's no numbers over here that we're adding together such that we could get any carry up here. It's not possible to have a carry here, so we're just going to put a 0 here. And then 5 plus 6 is 11, and instead of putting our 1 up here like we're used to, we're going to store our 1 down here in our separate carry number. And we're going to ignore it for now, but then we'll add it in later. 2 plus 3 is 5. And then 1 plus 0. And then also noting that we aren't carrying anything from this column to the next, so we're going to put a 0 there. 1 plus 0 is 1, and now we have our two numbers. Almost our sum. We just have to add what we got here to our carry right here. So 1 plus 0 is 1, 5 plus 1 is 6, 1 plus 0 is 1. 161, and we got the correct answer. Okay, so now let's translate this all over to binary. If I wanted to add two binary numbers together, let's say 11 and 2, let's do. So I think that's right. 8 plus 2 plus 1, that is indeed 11. And then this is 2. Because remember, just as a quick refresher here, whereas in base 10, what this number right here, 125, really represents is 1 times 100 plus 2 times 10 plus 5 times 10 to the 0, or 5. What this number here represents is 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1, which is just 1. So that's how our binary representation works. So now let's add these together, kind of using our good old-fashioned carry. 1 plus 0 is still 1. 1 plus 1 is 2, but 2 in binary is 1, 0. So we are going to have to carry here. So we put our carry over here, and we put our 0 here. 0 plus 0 is 0, plus our carried 1, we get 1. 1 plus 0, we get 1. Cool. Now let's do the same thing, same addition, using my carry method I introduced over here. So we start, let's name our carry right here. And just note that we're going to be adding this to our number. We're not carrying over anything in this first column because, again, there's no numbers over here, which we could possibly be being added together such that we have a carry right here. So now 1 plus 0 is 1, and we're carrying over nothing from this first column to the second. So we put a 0 here. 1 plus 1 is 2, which again in binary is 1, 0. So we put a 0 here, and note that we will be adding 1 to this next column. 0 plus 0 is 0. no carry over to the next column. 1 plus 0 is 1. So now, to get our total sum, we add together our carry right here, with our partial sum up here. So 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 is 1. Now let's make sure we got the right answer here. This up here is 11. This down here is 2. So we should get 13. This is 8 plus 4 plus 0 plus 1. And that does indeed equal 13. So we are good. We did our addition correctly. Okay, so that's cool. We have a systematic way that we can add together numbers in binary, but it seems to me like getting a computer to do this might be a little more difficult, especially if we want to optimize it so that our computer can do thousands and millions of computations every second. So to do this, we're going to have to look at our baseline logical operators that we can do on a bit level, and these are highly optimized at the machine code level encoding. So the ones that we're going to need, the operators that we're going to need for this, are the AND, the XOR, and the Bitshift operator. This is called the Bitshift. And let's quickly cover, kind of give a crash course on what these three things are and how they are used. So these first two are bitwise operators, the AND and XOR. And what this means is they look at 2 bits at a time, 2 corresponding bits and 2 numbers, and do some operation on them to result in either a 1 or a 0. So let's look at how AND works. Let's give an example number. Let's put 1, 1, 0, 1. And then our second number as 0, 1, 1, 0. If we are ANDing these two numbers together, that's kind of funny to say. Oh, ANDing these two numbers together, we first look at our first 2 bits and say, if and only if both bits are 1, the result is 1. Else, the result will be 0. That's how our AND operator is defined. So looking at these first two, 1 plus 0, or not plus, 1 and 0, I guess, that results in 0 because both are not 1. And now looking at the second column, we have the same kind of deal. 0 and 1 is 0 because we have a 0 and a 1, and for it to be true, or for it to be 1, both bits must be set to 1. Now looking at our third column, we have 1 and 1, that is 1, and then another 1 and 0, that is again 0. So this binary number up here and this binary number results in this binary number down here. Okay, so that's cool. Now let's look at XOR and see how this works. XOR is similar. Let's XOR 1, 0, 1, 0 with 1, 1, 0, 0. So XOR results in 1 if and only if one of the 2 bits is 1. Else, it will result in 0. So looking at our first 2 bits here, in our first column, we have a 0 and a 0. There's no 1s there, so we get a 0. Looking at our second column, we have a 1 and a 0. That our condition here, if and only if one of the 2 bits is 1, is true here, so we get a 1. And now looking at our third column, we have a 0 and a 1. Same thing, one of our 2 bits is 1, so we get 1. And then a 1 and a 1. 2 are 1 this time, not 1, and our condition is if and only if 1 is 1. So this is still a 0 because both, not 1, are 1. So that's how XOR works. Now let's look at our Bitshift over here. So what Bitshift does is it will shift our number, a specified number of bits. If I have a number, say 1, 0, 1, 1, and I shift it 2 bits to the left, because notice my arrows are pointing to the left. So I will be shifting my digit or my binary string to the left. What I do is take the 2 bits on the left of my number and nuke them, get rid of them, and then pad 2 zeros to the beginning. So 1011 bit shifted 2 to the left equals 1100, because these 2 over here again nuked, and then I padded 2 zeros there. So looking at another number, let's say 0111, bit shifting this 1 to the left will result in, because I'm taking this 0 right here and I'm getting rid of it and I'm padding another 0 to the beginning, will result in 1110. And I hope you kind of see how I got that answer. Okay, so now we have our 3 bit operators that we're going to be using to be performing addition. We're going to use these 3 operators and that is it. So how are we going to do this? How can we add 2 numbers by ANDing, XORing, and bit shifting? Well, we can start by noting that what I did earlier is I broke down, instead of just adding 125 to 36, instead of putting our carry up here, I stored it in a separate variable down there. We're going to kind of do a similar thing here. If I want to add 1011, so that would be 11 again, and I want to add that to 2, so hopefully to get 13. What I'm going to do is first calculate the partial sum, so that would be just ignoring the carries. So ignoring the carries here would just be 1001, and then I want to calculate my carry, which I know just because I'm a human and I have some nice neurons that like to do complex computations for me. I know that my carry should look like this. And then I can add these 2 together and then get my final result. But I need to get my computer to do that using those operators that we just looked at. So let's first focus on this partial sum here, right here, and see how we got that. Well, if we have one of our bits as a 1, we know we'll always get a 1, whether it's 10 or 01. 1 plus 0 is 1, and 0 plus 1 is 1. And so 1 and 0 makes 1, and we know if both are 1, we're going to end up with a 0. We know that if both are 0, we end up with 0. To me, that sounds a whole lot like our XOR operator. So let's try that out. If we XOR together 1011 and 0010, let's see what we get. We get 1 XOR 0 is 1. 1 XOR 1 is 0. 0 XOR 0, 0, and then 1 XOR 0 is 1. And hey, that's the same thing that we have over here. And that is why I showed you the XOR. So, okay, cool. Now we know how to calculate our partial sum. Now we simply need to know how to calculate our carry right here. Let's see how we got that. The reason this is a 1 right here is because the column preceding it has 2 1s. Because the column preceding this column has 2 1s in it, the succeeding column, this one right here, has a 1 here in the carry. So what we can do to calculate that is, let's write down our numbers again, is first perform an AND, A and D. ANDing that, 1 0 is 0, 1 1 is 1, 0 0 0, 1 0 is 0. So now we're almost there. Now we just need to bit shift this 1 to the left, because remember, when we carry a number, we aren't adding it to the same column, we're adding it to the column 1 to the left. We're going over 1. And that's kind of what this bit shift will do. And what this bit shift, or what this number will be after our bit shift, is 0, 1, 0, 0. So now we have our bit shifted number. And if we notice, this is the same thing as our carry up here. Isn't that nice? So, kind of, now that we have both our carry and we have our partial sum, we can add these two together and, well, that'd be cheating. We can XOR these two numbers together and get our final result. 1 XOR 0 is 1, 0 XOR 0, 0, 0, 1, 1, 1, 0, 1. And again, let's just check it. 11 plus 2 should be 13, and this binary number down here is indeed 13, so that gives us our answer. Now you might ask, well, what happens now if we get a carry adding these two numbers together? Because that will definitely happen. Well, we can kind of just do a recursive-like thing, where after we calculate our partial sum right here, and our carry right here, we can just call back our add function and add those two together, and it will automatically run through the carry and handle all that. And then if we get more carries, we can keep doing our add until we have no carry. Because when we have no carry, like if I was adding together 1, 0, 1, 0 to 0, 0, 0, 1, this is equivalent, the addition operator is equivalent to the XOR. XOR these two numbers together, I get the exact same thing. Oh, I did this wrong here. Should be a 1. These two result in the same thing. So I can just, in my code, check to make sure the carry is 0. And if the carry here is 0, because if I were to calculate my carry for these two numbers right here, I would be ANDing together this one and this one. I would get a bunch of zeros because 1, 0, 1, 0, and 0, 0, 0, 1 has no bits lined up together in a column, no ones lined up together in a column, so we're just going to get all zeros. So in my code, what I can do is first try adding together two numbers, and then after I add together my number and my number, or after I calculate my carry and my partial sum, if my carry is 0, I just return the XOR of my two numbers, because when the carry is 0, or that is to say, when there is no carry, addition is equivalent to XOR. But if there is a carry, I just run my addition again, and then again and again and again until I have no carry. All right, I think we have enough understanding now to go and look at some code now. So now over here in my terminal, what I'm going to do is first start up our Python environment. And what we want to do is define some kind of function so we can add numbers together, because we don't want to do anything like this. That'd be cheating. Instead, I want to make my own function, so I can type something like add 1, 2, and we'll add it. And right now, we don't have any function because we haven't defined anything. So let's do that. Let's define our add function. And what we want to do is add two numbers together. So we're going to have two local variables to this function, two parameters. Let's call them A and B, keep it simple. Okay, like I said before, we want to be doing some kind of recursive thing, because if we try and add together two numbers, and there is no carry, we know that we just have to XOR them. So in our best case, our easiest case, when there is no carry, we know we just have to return A XOR B. And in Python, the way you do that is you put this little caret here. Return A caret B is A XOR B. This is performing a bitwise operation on these two numbers. But remember, we can only do this. This will only be valid if, and only if, I might add, our carry is 0. And how do we know if our carry is 0? Well, if we AND together our numbers, A and B, this is the way you do it in Python, and we get all zeros, that means there will be no carry. Our numbers just kind of squished together, all nice like. So if A and B has all zeros, or that is to say, if A and B equals 0. So now we're returning A XOR B if A and B equals 0. But if that's not the case, if there is a carry, we have to do more work. What do we have to do? Well, if there is a carry, we have to calculate that carry, 1. 2, we have to add that carry to A XOR B. So if A XOR B, or if A and B, equals 0, so if there is a carry, what we're going to do is add together A XOR B with that carry. And remember from the notes that we just did over there, we know that to calculate our carry, we do A and B, and then we bit shift this 1 over. And that, surprisingly, is actually all that we need to add two numbers together using the bitwise operators or just bit operators in general. So let's kind of just review what this one powerful statement is doing before we type this in and start trying it out. To add two numbers together, in the best of cases, we know that all we have to do is XOR them together. If I have 1, 0, 1, let's go back to the drawing board. If I have 1, 1, 0, 0, and I'm adding this to 0, 0, 1, 0, this is a nice case where adding is equivalent to XORing. So, looking back at our code here, if our carry is 0, so if A and B is 0, I can just return the XOR of A and B and we're done. But if A and B does not equal 0, if there is some kind of carry, I have to do more work, or the computer has to do more work. And what is that work exactly? Well, instead, we have to add our partial sum, or A XOR B, to our carry. And the way we calculate that carry is first we AND our numbers together, see which columns which columns will result in a carry, and then we move that carry 1 bit to the left. And we add that all to our A XOR B. So let's try this out and see how it works. I want to add together 1 and 2. I get 3. It's magic. Let's add 5 to 8. 13. And just one more try, just for the heck of it, I guess. Let's add together some nice, real big number. Let's add 1 to it. And wow, it even works there. Well, isn't that dandy? We have just created an adder in Python without actually having to use our plus operator that is included for us. Now, of course, in Python, you would never want to do this or need to do this because your plus is already defined. But this is just kind of, or the reason I'm using Python here is it has some nice syntax, and a lot of people have it installed on their computer, and it's easy to has some nice syntax to teach on, I think. Now, the next question, of course, might be, well, how might I subtract numbers? What if I want to subtract 2 to 1? Well, I think that'd be something for another video. And actually, I guess just kind of as a hint, the way that you do it, the way you subtract two numbers, is by instead adding something called the 2's complement to it. But that's something perhaps for another day or for another video. Thank you. Thank you for watching. I hope you learned something, and goodbye.